Next up, we want to be able to use our calculator to find an angle. We need to go backwards. So here's the structure. We have a trig function that gets applied to an angle and produces a value. That value is a ratio of sides of a right triangle, and it could be other things. But so we're just going to call it a value. So we have the sine of 37 is 0.602. So trig function, sine, angle, 37 degrees is some value, 0.602. What we want to do, in this case, we were given an angle and we applied the trig function to find the value or the ratio. We want to be able to do this the other way around. We want to be able to undo this. We want to be able to start with a value and get at an angle. And to do that, we have to undo the trig function. We're going to use an inverse trig function to find an angle. We're going to use inverse trig functions to find angles. This is the same thing that we always do. If we see some multiplication, we undo that with its inverse, division. If we see some subtraction, we undo that with its inverse, addition. If we see exponents, we undo that with their inverse, other exponents. So sine takes an angle and gives you a value. The inverse trig function will take a value and give you an angle. So let's see how it works. What we're going to see is that sine inverse of 0.602 will give us 37 degrees. This is just how inverse functions work. So if the sine of 37 is 0.602, sine inverse of 0.602 is 37 degrees. This is our notation for inverse, for sine inverse. We use a -1 and we put it in the exponent. It is not a -1 exponent. This is one of the worst decisions we've ever made in creating mathematical notation. We were just like, oh, I should stick a -1 exponent on there to indicate an inverse. Yeah, it'll look like a reciprocal, even though it's not a reciprocal, it's going to be the inverse function. Everybody knows what we're talking about. Everybody will know it's not 1 over sine. And then like years later, fast forward years later, we're like, oh crap, we have to make sure it's something, we have to call it something else because everybody's like doing like cosecant. This is a disaster. Who decided this? And then we're like, oh, well, we did. We, like I was there. I wasn't there. Another people. So this is notation. And the way you read this, sine to the -1, you say sine inverse. Sine inverse of 0.602. Another notation that we might use for this is to say arc sine of 0.602 is 37 degrees. That one you can just pronounce arc sine. and it means the inverse of sine. I'm pretty sure this is what we started using first. And then later I was like, oh, this is so much right. I'm just going to use a -1 exponent. So to access the inverse trig functions, you'll notice on the calculator in blue above the sine button is the inverse. You can't, it's hard to see here, but there's a sine to the -1. Above cosine is cosine to the -1, and above tangent is tangent to the -1. So that's inverse sine, inverse cosine, inverse tangent. If I ask my calculator, what is, so to activate the blue functions, you press second, so second sine, and your calculator displays sine inverse. Sine inverse of 0.602 is 37. And that's it. Notice it didn't come out exactly to 37 because I didn't use exactly the sign of 37. If I had used more digits, it would end up being closer to the 37. The more digits I use, the closer we get to the actual 37. Any questions? On the phone style, we also have to access this. We have to access a second function. So phone style, you'll see sine, cosine, and tangent. You don't see what the alternate functions are until you press second. So press second, and then that changes what's displayed on the buttons. So once I press second, it says sine inverse. But that's not how the sine button works on the phone style calculator. I have to put in the number 0.6018 and then press second sine inverse to get my 37-degree angle. Some calculators will hold the second function until you turn it off. Notice that I did stuff over here and it's still sine inverse, cosine inverse, tangent inverse until I turn second off, then hit sine, and I can go back to my original. So some have sticky second function buttons. The TI-84 doesn't do that. Once you press, it only works for the next button press. So if I press second sine inverse and I press cosine afterwards, it's not going to give me the cosine inverse. It just gives me regular cosine. So TI-84 style, the second function button is not sticky. It just does one, whatever the next thing is. On the iPhone, at least on this iteration of the iPhone, it's a sticky button. And it stays in second function mode until you cancel it. Any questions? Is everybody okay? Are you sure? Is everything super easy? Barely an inconvenience? All right, let's find some angles. Here we have some angles that we didn't find. So in this first example, we have the tangent of theta is 3/4. So if I want to know what the angle is, the tangent of theta is 3/4. I don't know what angle is. I don't need to use trig functions. I'm going to need to use trig functions, inverse trig functions to find angle. So I'm going to do the inverse tangent of 3/4. So I need second inverse tangent of 3/4. This is why I like the TI-84 for this particular operation, because I can just type it like I would see it. And that is a 36.9 degree angle. I didn't specify where to round it, so that was my fault. Note that we have two other descriptions of that angle. Sine of theta is 3/5 and cosine of theta is 4/5. So if I do sine inverse of 3/5, I get the same angle because we're describing the same angle. And if I do cosine inverse of 4/5, we get the same angle because we were describing the same angle. This is good news. We have multiple ways to get at a piece of information. This is bad news. We've got multiple ways of getting at a piece of information. And that means we're going to have to choose one. Any questions? When you have the fractions, you got to remember how your phone calculator works. Remember, the sine and the sine inverse buttons only take the sine or sine inverse of what's on the display. So if I want the tangent inverse of 3/4 for this angle, I have to figure out the 3/4. 3 divided by 4. I can't hit tangent yet because that's not what 3/4 is. That's just the 4. 3/4 is 0.75, and I want the tangent inverse of that. Second tangent inverse. Questions? If you happen to know that 3/4 is 0.75, you can just type that in directly. So for 3/5, 3/5 is 0.6. Second sine. Oops, nope. Sticky buttons. That's the end. But if you're not sure, you're going to figure out what that fraction is by hitting equals before you use your inverse trig functions. Like on cosine of theta is 12/13. I don't know what the decimal approximation of 12/13 is, so I'm gonna have to ask the calculator. What is 12 divided by 13? I had to hit the equal sign to get that fraction up there, and then I can second cosine, find an angle of 22.6 degrees. Any questions? How's that okay? Busy day today. We did a lot. So, given a right triangle, we have the sum of the angles is 180 degrees. So that's all. We have the right, a right triangle, so we get to use the Pythagorean theorem. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We know how to make the trig ratios. We also now know how to go and figure out angle. That's a good day, I think. Any questions? Comment? Motion to adjourn? No, keep going. I'm just kidding. I move we adjourn. I will also second it because I know no one wants to say anything. Because you think it's like some kind of trick. All right, that's going to do it for today. I will see you all on Thursday and we will solve some triangles. Everybody have a good couple of days and thanks for playing.